Okay, this question is similar to a question from the 2013 VCAR, talking about a continuous random variable with a probability density function. Of course, we know that for PDF, this area between 1 and 0 will be equal to 1. This question is saying find the expected value. Now, if I want to find the expected value, that's going to be the integral of x times pi on 2 cos pi x on 2 between 0 and 1. Now, of course, the problem is that non-calculator, we're not sure how to anti-differentiate x pi on 2 cos pi x on 2. So what they've done is they've told us that if we were to differentiate x sine pi x on 2, we would obtain this. And so this question is incorporating integration by recognition. Now, for this type of question, what I like to do is, I know that if I differentiate x sine pi x on 2, I obtain this, which means that if I were to anti-differentiate what I have here, I would obtain x sine pi x on 2. And so that's what I like to write first. I like to say that if I was to anti-differentiate what's written here, pi x on 2 cos pi x on 2 plus sine pi x on 2, that would give me x sine pi x on 2. Now what I'll do is I'm going to rearrange my equation because I need to find integral of x pi on 2 cos pi x on 2, which is here. So I need to take this integral sine pi x on 2 dx to the other side. So we'll do that. So here we've got integral pi x on 2 cos pi x on 2 dx is equal to x sine pi x on 2 take away the integral of sine pi x on 2. And so we've succeeded now in terms of we need to find this integral and we have it here. What we need to do is we need to actually anti-differentiate sine pi x on 2. Now we know the antiderivative of sine is negative cos. So the integral pi x on 2 cos pi x on 2 is then going to be x sine pi x on 2 plus cos pi x on 2, but we need to divide by the diff of what's inside the brackets. What's inside the brackets is, the diff of that will be pi on 2. So this is divided by pi on 2, which is the same as multiplying by 2 on pi. Now what we can say is that if we need to anti-diff this from 0 to 1, it's going to be the same as if we sub in our values into the anti-diff of from 0 to 1. And so now we have to work with circular exact values. And you can see VCAR likes to combine a lot of things here. We're combining integration by recognition. We're combining probability with a continuous random variable. Now we're looking at circular exact values. And there's going to be a lot of brackets here, a lot of negatives. You've got to be careful. So this is equal to, so let's sub this in carefully. I've got 1 sine pi on 2 take away 2 on pi cos pi on 2 all of this take away when I sub in 0. Now when I sub in 0 into here, this is going to just be 0. If I sub in 0 into here, it's going to be 2 on pi cos of 0. Now we need to know our circular exact, of course. So you need to know sine pi on 2, that's 1. You need to know that your cos pi on 2 is 0. And your cos 0 is 1. So therefore, your expected value is 1 take 2 over pi.